Okay, good. Alrighty. Oops. Matthew asked me to talk to you. Oops. Oh, come on. What did I do wrong now? Zoom share. Matthew asked me to talk to you about microwaves, and so I'll give you a quick tour and hope I don't bore you too much. So tell you a little about me.
The screen share.
Yeah,
We
looks
only
like-
see the very top of your screen.
Far from you. Okay, this is where I live on top of a hill in Vermont. I'm looking west toward you, but it's can't quite see over that mountain. So anyway, and it's not quite this many flowers yet. The snow just melted. I was skiing on Easter Sunday, so and I'm retired here. I graduated 50 years ago next month, so a little older than you folks, but I went to Newark College of Engineering, now NJIT, which is, they claim, the #1 school in the country for return on investment. And got some antennas on the house. And that's the view looking out the window here in the basement. And we have really dark skies here, which you probably don't there. That's a comet we had a couple of years ago. And then we have winter here. And it gets worse than that. So anyway, microwaves. Well, assuming you've been in ham radio at all and done more than talk on a walkie-talkie, after a while, you get to where you need a new challenge and maybe operate from mountaintops, beaches, contests, build your own equipment, play with antennas, do digital stuff, television, whatever you like, see how far you can get. We call that DX. Have fun, or whatever you want. There's lots of amateur microwave bands, lots of spectrum that the good old cell phone people are trying to steal from us all for 7G and 8G and whatever else they can think of. So here I am on the cover of the Amateur Radio magazine. I'm the guy in green. That's my friend Chip in front. And that's on top of Mount Washington, which is about 40 miles from here, and said to have the worst weather in the world. So from my experiences there, it's pretty close. Here's another mountain with a lot of hams set up with their microwave stuff. Here I am on Mount Washington again. And here's a normal day up there. So, and then sometimes the microwave activity gets a little too intense. That's on Block Island off Rhode Island. Nice place to go. Martha's Vineyard, another island, mountains. And every year our club has a picnic where we all bring our gear and try it out, see whose works best, and see whose doesn't work. And you saw some antennas there, microwave antennas, or have high gain and they're large. There are many wavelengths across, and the HF antennas, low frequencies, have low gain and they're small, maybe a half wavelength then. So a lot of hams like to play with antennas. A friend of mine makes little log periodic ones like these on printed circuit board. Makes thousands of them, and other people, you can find them all over the web at ridiculous prices, or you can buy them from him for reasonable prices. These are some horns I've made, found, whatever. And we've done some 3D printed antennas. You just metalize them. They work pretty much as well. You can make antennas with wire loops like that. Helical antennas. You've probably seen those somewhere. A lot of us play with the TV dishes that used to be on your roof, and now we get them at the landfill at the right price. One antenna I had is a vertical periscope where the works is on the ground and there's just a flat reflector up in the air, which I rotate around to point at different things. There it is up in the air with a lot of other antennas on my tower. And with my neighbor has a 16-foot dish in the backyard, and we've done EME, Earth, Moon, Earth, bouncing signals off the moon to make contacts with all over the world, or half the world, because only you have to both see the moon. And that's the way we rotate it with a pole and push it. Highly sophisticated. One of these days, we're going to motorize it and put a fancy digital readout on it. But first, you get it on the air. That's my rule. Get something working, get it on the air, use it, make it fancy later. I've been, there's a local Makerspace, and I've been making antennas there on CNC machines. You probably have something like that at your school. And a few years back, I wrote a microwave antenna book. I started out just writing things down so I wouldn't forget them, and pretty soon other people started looking at it. I made it a book, and you can find that online. For some of our microwave long distance contacts, we use range scatter, where there's a mouse. Go back one, go back. So here there's a thunderstorm, but halfway between two stations, and we can scatter off that and off the raindrops and actually extend the range greatly. So here's another one where rain wasn't in line, and you can scatter sideways. And sometimes the thunderstorms get a little too intense in this part of the world, or out in the flat parts of the world, not at our end or your end. And microwave radios. Well, a traditional one, microwaves. So we have an ordinary radio. We have a transverter that changes frequency to a higher frequency in both directions, and a power amplifier. Or we can have multiple of them for different frequencies. Or we can use a software-defined radio, basically A to D and D to A, and a power amplifier. So, but one of the things I've done over the years is design simple things, cheap things that people can get on the air and try without great effort and expense. So transverter, as I said, converts the lower frequency to a higher frequency to transmit, back again to receive, and usually from VHF frequencies for the commercial radio we use at the source. So my design philosophy is that gain is cheap. You can get microwave integrated circuits for less than 10 cents a dB. Ordinary printed circuit board, a couple of dollars, ordinary components, and get reasonable performance. Not ultimate, but easy to make and works, and easy to build, and make it modular and expandable. So here's a bunch of them I did for 6 different microwave bands. You see, it's just printed circuit boards. The lower ones, the printed filters. All the magic's in the board. And for the higher frequencies, uses ordinary plumbing fittings tuned with a screw. So again, make it cheap, make it work. So now, these are all handmade and these are hand tuned. And, I worked in industry for years. And if you're making $1 million in something, you do the engineering so you don't have to tune things by hand. But if you're making one and somebody else is making one, you got time and parts are make it cheap. So again, printed, simple, low power, put it in a lunchbox, ready to go. Walmart was clearing out some lunchboxes for 50 cents, so I made one in a lunchbox. This is a little frequency synthesizer from China for the local oscillator. That's an Arduino that does the control, and there's the RF part. So,
So, quick question, how high does the synthesizer go up to frequency base?
sorry, I can't hear you clearly.
How high does the frequency synthesizer go up frequency?
The synthesizer or
Yeah,
the transfer?
the synthesizer for the local
Okay, well,
oscillator.
oh, that says 3,300 megahertz. That goes up to about 4 gigahertz for, I don't know, $29. Stuff on eBay is amazingly cheap, and some of it's pretty good, and some of it's just cheap. So, yeah, sometimes you might need a relay to switch from the transmitter to receiver. You can use a fancy one, or you can get ones that are come out of networking boxes. Cheap, and they do the job. There's a relay. So anyway, and these are simple and cheap things. You can generate more power with an amplifier, lower noise with a preamplifier. You can have real metal filters so that they still work when you're near a TV station or something. Those printed filters are pretty good, but they don't have rejection for really strong signals. So anyway, and you can do a better job packaging than a lunchbox, but those are enhancements. As I said, make something work, get it, use it, play with it, then improve it. It's a very sophisticated thing I made for soldering chip capacitors by hand. You hold it down with a little lever and a toothpick on the end and solder with soldering iron. You don't have to have a fancy pick and place machine if you're making one of something. Here again, this comes in at 1 gigahertz, comes out at 10 gigahertz, and 2 steps, and the little pipe cap that provides filtering. You just turn the screws. So any of these you can do for under $100. If you scrounge the parts, you can do it a lot cheaper. Anyway, so that's what I do for to help people get on the air, learn about microwaves, use cheap test equipment. Today you can get a nano VNA for $60 or something, and a tiny SA spectrum analyzer for a little over 100. These are some of the other cheap test equipment. Notice nothing says Keystone or Rodian Schwartz or Agilent or any of those high-priced things. fact, if you, so here's a little thing I made recently. To measure power works from 1 megahertz to 10 gigahertz. Little module from China, power detector IC, bar graph driver here for the LED bar graph, and a 9-volt battery and Altoids. For some reason, hams like to build things in Altoids cans. I can't stand the mints, but a friend of mine had a bad habit and gave me a big bag of them once. This new toy, Tiny SA spectrum analyzer, works to up to 20 gigahertz. Here it's looking at 10 gigahertz. I think I paid $160 for that. And in the latest IEEE microwave magazine, they compared one of these to several $100,000 HP one. Concluded it's not quite as good, but the other one was a little better, but not proportionately better. So I want something in my pocket. I want my price range, and if I got a lab that somebody else is paying and wants it everything certified, then you go for the big bucks. Here's the VNA vector network analyzer. Again, little handheld thing. Up to, I think the new one's 6 gigahertz and a few more dollars, but okay. And we can buy commercial microwave stuff, but that's not much fun. Here's one made in one of the Eastern European countries. A couple of $100. Looks similar to mine, printed filters, but they've got some fancier control. And here's how you can receive 10 gigahertz for $20 with a LNB from a satellite TV, bias T to get some voltage to it, digital TV dongle, and Android phone app. So, that's actually copying a signal there. Question?
I don't think yet. Yeah. I don't know if people are holding them till the end or whatnot.
Okay, so we had a microwave conference this past weekend, and one of the speakers was Hasan Zhang, who's actually the president of the RPI Radio Club here. He was telling us about his SDR microwave system. So, traditional receiver and SDR. I'm sure most of you are familiar with that and probably do a lot more with computers than I do. I've only been using them for 60 years. But anyway, so he used analog devices Pluto Plus and an amplifier, switch, and an Arduino, and he's got everything I made in all those modules roughly equivalent, and some software. So
is he using?
Show you where to find links at the end.
He's using direct down conversion or what? Or is he doing a super heterodyne kind of structure on there?
Okay, we're gonna have to get better audio before I can understand your questions. So I suspect you have a speaker on the laptop up front, and you're gonna have to walk up there. So anyway, here's his thing.
Here. I don't know if you can go back really quick. Sorry, stand closer. I was saying, is it direct down conversion, the receiver back there?
Yes, it is. This analog devices thing goes up to somewhere between 3 and 6 gigahertz, depending on how well you want it to work. has two transmit, two receive channels. You can do, MIMO, multiple input and output if you want to get real fancy with it.
Both.
And let's see, that they used to be $150. I think they might be up to 300 with the plus model. But again, there's most of your radio, and you can do all sorts of things with it. So, so what he does, yes. Yeah, so here's his diagram. Pluto here. Amplifier, switch, transmit, receive, and filters so that you're only transmitting on the frequency you want to transmit on. But that's the problem with these very wideband things is they're often more outputs than you expect. And there's software, freeware you can find on the web, SDR Angel, microphone and a key, and the Arduino, and you're on the air. I think there's a laptop involved with the software, but that's pretty much always the case. There we go. Yeah. Here's a little detail: 12-foot D to A's and A to D's. Not the top of the world, but you're looking for something simple and cheap, you use what you got. So, anyway, my advice is always get something together, get on the air and have fun. Learn by doing, and go for it. So, okay, here's some guys in San Diego at a Maker Faire. Yes, there, that I know. The San Diego Microwave Group. This a couple of years ago, and they made little 10 gigahertz fox hunting radios so people could, kids could wander around the auditorium and try to find the signal source. With the fairly direct antenna on the front, and so apparently it was pretty popular. But anyway, just tried to touch on a few things. That's my website. And from the conference this weekend, microwaveupdate.org. So, and from there you can get to lots of places. So, for questions, I'm going to have to ask you to get a little closer to the microphone, and then we'll see what we can do.
Okay, well, I guess if nothing, a round of applause for questions. Hopefully, something like that.
So what would you recommend for getting started into microwave? Like what bands, what kind of hardware, kind of projects? I think our club was interested in getting a microwave station up and going. We don't have, I think, anything around this area.
Okay, you're in San Luis Obispo, is that it?
Yep, San Luis Obispo. There's
Yep.
I don't think there's much around here for microwave groups.
There's the ones I know of are in San Diego, San Bernardino, and in the Bay Area. So you're halfway in between, right?
Yep, yeah, there's a lot of stuff around the Bay Area and south of here, but
Right. So the most popular microwave bands are 1296 megahertz, 1.3 gigahertz, and 10 gigahertz. So,
yeah, I was thinking of possibly trying to create a 10 gigahertz beacon station for the club so that people could get their radios and antennas tested off of it. But I don't really know where to start, what kind of equipment
okay.
to build. And
Let me see if I can run back a few slides. there. So if you took my little beacon board here and one of those Chinese synthesizers, you get a few milliwatts out here, which is enough for a local beacon to start tuning up other radios. And so that's about the simplest and cheapest way to go. And then you need an antenna. You start with a paper clip and work up from there. But
Yeah, what would you recommend for antennas? I think the club could probably do dish stuff, but how many like non-dish microwave antenna options are there? Like how usable would a log periodic or just a horn be?
how many options are there? Infinite number. But for beacon, you usually want it to be more omnidirectional.
Yeah, no, I meant for like for a user that wanted to like point at the beacon and tune a radio.
For user, usually a horn antenna is a good one. A dish if you want to get fancy, but that gets trickier. Or a log periodic is a low gain antenna, but generally works. But if you're starting out really simple with well, there's a horn antenna made with some copper and a torch, this one. So the LNB has the horn built in here. And so if you get started playing around and get a feel for it, you made a simple beacon as I showed you, and something like this with just the TV LNB and the dongle. That's a simple, cheap way to get started. If you want to get sophisticated, you can use Reed Heisen's paper and see how you do it with an SDR. But yes, it does help to have some people who have already done it to help you. I agree.
Yeah, I'd be interested in doing it with an SDR, hooking something like a Pluto up to a mixer to go to 10 gigahertz or so. But
yeah, that'll do. I mean, that's what I do. But my SDRs are at the lower frequencies and a little more sophisticated than that. But yes, I think all my radios are SDRs now.
The one thing too is that if we go the transverter route, about getting that local oscillator signal in there to boost it up high enough.
well, you just use like a GPS DO and it's locked with.
Well, to get up to 7-8 gigahertz, so you can bump your signal up there.
Yeah. You just use a phase lock loop so that you can multiply the frequency. Actually, yeah, that's a good question. What would you recommend for stable frequency sources for these? I know you have to get pretty good accuracy if you're going to do like a PLL to boost the frequency, right?
So the frequency accuracy you're asking.
Yeah. What do you recommend for good frequency accurate sources for like a local oscillator?
These cheap synthesizers are actually not bad. They're within a few kilohertz, and if you're at 10 gigahertz, and if you're using an SDR for a receiver, doesn't matter much. You can find the signal on the screen. That's good enough. But if, on the other hand, if you want it really accurately, some minor locked to a GPS, so they're 1 part in 10th and 9th or 10th. So And it isn't that hard to do, actually.
Yeah, you can buy those pretty cheap on like eBay, right? Like around
Oh, yeah.
$100 for just a GPS disciplined.
Yep,
So 50 or 50
But
for GPS deals.
GPS,
Yeah. You're just saying this
One
one
to-
oscillators.
$100 to $200 usually. I'm not terrible.
Yeah. Doesn't frequencies they want. More questions? Anyone out in the audience have questions? Stop the recording. For a bit. All right, well,